There we go. Cool. So prepared I am. So while this thing is coming to life, let me ask you a couple of questions. Now that you've all kind of worked with logs a little bit, what would you say log base 8 is 64 is? 2. All right. So realize now, if before today you're like, holy shit, logs are hard, logs are insane. No, they're not. No, they're not. The freakier problems you got to think about a little bit because you're still not used to it, but still. So what's the answer to a log always? The answer to a logarithm is always what?
The exponent.
The exponent required. It's always a power. And we'll see that the properties of logarithms are the same as the properties of powers, because that's what a freaking log is. It's just the power I need. So what would log base 2 of 8 be? 3. Why? Because I need 3 2's to multiply to be 8. So how can you kind of check yourself always? 8 squared is 64. Check. 2 cubed is 8. Check. In fact, the way we read this is log base 2. See how 2 is the base? Log base 2 of 8 is 3. 2 to that power is this. You guys feel a little better about it? All right. So there are some things to fill in, obviously. So let's go through this sheet here. There you are. On the first page, real quick. So if you do this, 2 to the negative 1 is 1/2. This was kind of, I was hoping this would help on the next page, on like that problem there. What is 2 to the 0? 1. And then you turn the page and you kind of forgot that. 2 to the first is 2, 2 squared is 4. It's amazing. So if you plot these points, I was kind of fine if you didn't get a complete picture yet, because you don't know what the shit's happening beyond those points. I don't blame you. This way you could imagine, what would 2 to the 5th be? 32, right? What's 2 to the 12th power? Holy shit. Do you guys see what I'm saying? A little bit? This is related. I don't know if you guys have ever heard the thing about, would you rather I give you $1 million right now, or would you rather I give you a penny today, and then I'll double that tomorrow, and then I'll double it again the next day for the next 30 days? All right, people mostly say I want the million, but you would make a lot more money if you did the second thing. If you don't believe me, get your calculator and do 2 to the 30th, right? Or even just 2 to the 29th if you want to quibble about what if it's a month with 30 days. 2 to the 29th, somebody help me out. It's probably going to see like E something.
536 million.
All right, 536 million. So you want $1 million or at least 536 million because the day before I gave you 2 to the 28th. Right? And in fact, I mean, it's pennies, but still, if you divide by 100, it's 5 million. Plus about 5 million the day before. You guys, we're not used to how a function that grows as quickly as this does. Have you guys ever watched a movie about viruses spreading? Have you guys ever watched about a movie about a monster growing? And they say something like, it's spreading or growing exponentially. Well, there you go. It's like, well, you must have seen pictures like, I'm going to do it up here so people at home are like, what the shit is he doing? You must have seen pictures like, well, today, I mean, here's the city, and today it's here, tomorrow it's going to be here, the next day it's going to be there, and the next day is the world, shit, you know. Because exponential growth is insane growth, really. It grows so much faster than everything. And if I make the base 3, forget about it. It's going to grow so stupid quick. Now, on the other side, so on this side, I know it's just going to kind of take off. That's what I'm trying to make you understand. If I let these get big positive, it's just going to take off. So what's it going to look like? Well, at 0, it's 1. At 1, it's 2. At 2, it's 4. And then it just kind of goes, wah! Because at 3, it's 8. 4, it's 16. 5 is 32. Holy shit. And if the base was 3 or 4 or 5, then it's really insane. So also this way, the same thing happens, just in reverse, the opposite. It shrinks very slowly. Yes?
And isn't it true when it shrinks, it never touches 0?
Beautiful. That might be why I wore this shirt today. Not to make you feel bad about not passing or something. That's not my point. But the idea of the asymptote, right? You can never raise something to a power and make it zero. You can't. Because I was telling a few people, if I raise something to a really big negative power, it's still going to be 1 over something. It's not going to be 0 over something. That's the only way you can make it equal 0. So back here, we know at -1, it's 1/2. At -2, it would be 1/4. So it always gets half as close. Has anybody ever heard of Zeno's paradox? And you're all like, math people, just stop it. Nobody's ever heard of Zeno's paradox? So you've heard of it? No? Okay. Man, he's like, I was just moving my head, man. Zeno's paradox, poor Zeno's kind of stupid, I always thought when I first heard this, but Zeno's paradox is he can never make it from this town to the next town because he has to go half the distance, and then he has to go half that distance, and then he has to go half that distance, then he has to go half that distance. So technically, he would never make it there. Does that kind of fall? Now, obviously, you're like, I've made it to towns. And when I first heard it, I'm such a smartass. I'm like, just tell Zeno the town is twice as far away as it really is. Damn dude's there. Next. I mean, all right, you guys are like, what the shit? All right, but this is kind of related to it. If I keep getting half as far away from the x-axis, always half as far as I was, I'm never going to make it there. I'm going to get as close as you want me to be to it, but I'm never going to actually hit it. You guys follow that? If you cut a number in half and keep cutting it in half, are you ever going to make it 0? Because what do you take half of to make 0? What half of what is 0? Come on, tell me. 0. So you have to be at 0 to make the next step 0. So you never get there. If it's something that's not 0, half of it is also going to not be 0. Half of that is also going to not be 0. Half of that is also going to be 0. Right? Do you guys see what I'm trying to say? That's another reason why there's an asymptote there. Asymptotic. In this term, it's going to be horizontal asymptote. Okay, so the exponentials, 2 to the x, 3 to the x, 8 to the x, they all have that same shape. Just the bigger the base, the quicker the rise, right? And the quicker the fall the other way. Exponentials are used for population growth. Right? Throw a few rabbits in a room and some food. Wait a while, again, more rabbits. And then wait a while longer, we got a problem. You know? I always want to talk about tribbles too, but it's not a lot of Star Trek people. Tribbles? Star Trek? All right, I'll stop. And if you look at it the other way, look at it this way, that's used for something called radioactive decay. Like, do you guys know Chernobyl? You might know Chernobyl from some stupid-ass horror movie from a little while back, but Chernobyl was the horrible thing that happened in Russia when they had the nuclear reactor kind of meltdown. And so the half-life of the material is insane. It's like thousands of years. So you're not going to be able to live there or have anything grow there for thousands of years because it's going to take that long for it to get to a point where it's not so radioactive that it's going to hinder life. You guys kind of follow? That's what, when you hear radioactive decay, this is the graph that they would use to model that. Okay. Maybe. Where did I put that? I was everywhere just now. There it is. Okay. So I was hoping, now please realize logarithms are not the same as radicals. In fact, if you see the difference, that might even help you get the idea. Radicals are all about what was the base. So square root, I know the power is 2. What's the base raised to the second power to make 64? 8. Cube root is 64. What base do I need raised to the third power to make 64? 4. You guys with me? Logarithms are, here's the base, I don't know the power. Do you see the difference? Roots, I know the power, just not the base. They're kind of backwards. Logarithms are also backwards, but I don't know the power, I need to know the base. We'll place it wrong. Yeah?
So if you have like a log of y to 3 equals something, you take the reverse.
Oh, you're getting a little ahead. Well, eventually we're going to be working with these in equations. Is that what you're trying to say?
Yeah.
Eventually. But we have to first talk about exactly how the opposites work. I like it. We're not there yet. Yeah, we're just learning how these things work by themselves. I like it, though. We will get there. So here I made you kind of go through the backwards thing here. 2 cubed is 8. Right? But we need a symbol to represent that. We don't like to have this like empty space bullshit. We don't like that. We want a symbol that we can apply. We want a thing we can do to something. So that thing we do is log. Right? So we're going to find here, log base 2 of 8 represents the same thing as 2 to the what is 8. That's just the way we represent that. Again, poor choice of symbol, but we just get past that. Yeah, 3. Please just tell me the answer. So these guys, the first couple hopefully weren't too bad, once you kind of get the idea. So how many 3s multiplied by 81? 4. How many 4s multiplied by 16? 2. And another way to say this is the power that 4 needs to become 16, and that's why the answer is 2. What power does 7 need to become 1? Well, everything needs the power of 0. The power is yours. All right, and then no reference.
No 4.
4. Yeah, I need 4 2s to multiply to 16. This one is really funny because it's so damn easy that it's hard. But what do you raise b to get b to the 8th? Well, then you kind of answer your question on the way there. 8. How do you check yourself? Well, b to the 8th is b to the 8th. I like it. Don't feel bad if you messed up on that first. Like I said, it's just so damn easy. Like you make it hard. It's human. This is really all about do you understand powers. So what do I do to 5 to make it become 1/5? What power do I use? Yeah, -1. 5 to the -1. Jeff, get over there. Is 1/5. Is what a negative power does. So anytime I have a fraction inside, I'm almost guaranteed it's going to be a negative power that I need. So here. Not only do I need a negative power, but I also need to make 3 become 9. So it's going to be -2. I'll make it flip, and square to make it become 1/9. I like it. Now, let me slow down for a second. The basics of logarithms are easy. I'm not even going to equivocate about saying that, because it is. It's just easy. It's just a question of knowing what the question is, right? What does that symbol mean? What does it want from you? What do you want? This one tripped you out, which is the purpose. And I wanted you guys to kind of investigate the hell out of this shit a little bit. I can make a number, I can apply a power to a number and make it really small, right? Apply -1 becomes 1/7. That's already pretty damn small. -2 power makes 7 become 1/49. That's really small. -18 billion power, I don't know why I love that number, but I do. 7 to the -18 billion is 1/7 to the 18 billion, which is stupid small. For most humans, that's basically 0. But for math, that ain't 0. It's 1/something, ain't 0. You guys with me? You can never make 7 become 0 by applying a power to it. Ever. You can't. So this is undefined. And this, of course, goes back to this idea. You cannot make the output 0. Because it can never get to the x-axis. You just can't hit it. You can't make the output 0. So this is undefined. Sort of related to dividing by 0. That's this here, really, to be honest. So here, we have an undefined situation, so I have an asymptote there. I'm not allowed to be there, because if I have 1 over, what is this one? I forget. 1 over x, do they even have an equation there? Sure. 1 over x minus Gandalf. At Gandalf, there will be an asymptote, because if I try to plug Gandalf into that equation, I get 1 over 0. You guys with me? And that would be undefined. This, if I try to plug 0 into the log function, the answer is undefined. There's an asymptote there for that one. How are we doing? Everybody all right? You guys always have pain close on your faces. All right, this one, you might think you have to use a calculator or something, but what is 0.1?
1/10.
Yeah, 1/10. And then it becomes a problem just like up here. So log base 10 of 1/10 is -1. You've got to flip that bad boy to make it become 1/10. What about this one? This is another one that's kind of like in your face. It's exactly the same problem as this. What if A was 3? Then 3 squared would be 9. These are the same problems, right? So they should have the same answer. So sure enough, what's the answer to this one?
-2.
Yeah, you got to flip it and then square it. So that's -2, the same reason that was -2. And then finally, our favorite problem. I don't know, there's a toss-up between these two, but this one definitely was one of the favorites. And let me just say, I've said this to most of you guys, I think, but that is the power that 7 needs to become 12. If I say that, are you guys cool with it? If you look back at your answers from the earlier problems, it's exactly how you got them, by thinking of it that way. That's the power that 7 needs on it to become 12. So what do I get when I put that power on 7? Well, I get freaking 12. That's what it does. I like it, maybe. So let me pick on this one problem in log base 4 of 16. That is the power that 4 needs on it to become 16. So when I raise 4 to it, I'm going to get 16. And sure enough, what is log base 4 of 16?
2.
It's 2. And 4 squared is 16. So that one, I know it's a nice number. It's a number 2. It's a nice number. And then I can do 4 to that nice number. And I can actually work it out. Is this a nice number? No. Can somebody give me an estimate for it?
It's like 1.27.
Oh, okay. I like. Damn. Can you be a little more precise? No. Don't reach for it. Okay. Reach for the calculator. Yeah. So it's going to be between 1 and 2, closer to 1, because 7 squared is 49. 7 to the first is 7. So in between. But I don't care what that is, because I'm applying the same base to it. That makes it an easy question. So it's sort of like if I said, simplify the cube root of 111.4927 by hand. And I said, oh, wait, I forgot something. Right? Isn't that an easy problem now? Do you give a shit what the cube root of this is? No, because the next thing I do is I kill it. That is exactly what is really happening here, is these kill each other. They are inverse functions. Just like a cube root and a cube kill each other, a 7 base to a power and a log base 7 in the power will kill each other. And look at it real quick. Sorry. This problem. Log base b and b to the power kill each other, so that's another reason why the answer is 8. So there's more than one way to look at that, but the inverse properties normally are the easy when you just cross through the shit. So I'm sorry, what's up?
I was just going to ask, they have to be the same base for you to do that, right?
Exactly. Like if it was 8 to the log base 7,
You're fucked, yeah.
it's sort of like me saying, do this by hand. Oh wait, I forgot something, and I put a, 4th power here.
Yeah, that's it.
Ooh, thanks, Jeff. Right, I'm not going to do that to you. Not ask you to do it by hand.
What if it was asking on G49 log 7 to 12?
Oh, okay. Let's look at 49 to the log base 7 of 12. All right. I don't know how other people feel about that question. That's a really good question. Now, watch. 49. Why'd you pick 49? Because it's still
A common
is 7, really, right?
Yeah.
So let's uncover it. What is 49? 7?
times
Sure, but let's talk about powers, because that seems to be what logs are all about.
7 squared.
7 squared. Now, I don't know if you guys... Now watch this. You ready? There, I just wrote the same thing twice.
Yeah.
Right? Because isn't 2 times log base 7 to 12? Isn't that the same thing as log base 7 to 12 times 2? That's related to, I could put the cube on the inside or the outside when I rewrite something from rational exponents to radicals. It's the same idea. And so what's 7 to the log base 7 to 12? It's 12. And what's 12 squared? 144. So you can kind of make a general statement then. 49 was the square of the base involved. So the answer is going to be the square of what the answer would have been. Now, did we just go a little further than I was planning, of course. But hopefully, that was a good question. Yes.
Not like, I know that that's right because you explained. Well, like I was thinking like 49 log 7 to 12. What if like log 7 cancels out the 7? It would still be 12. Oh.
But see, it doesn't work that way.
Doesn't work that
You
way.
have to uncover the base by rewriting it.
Okay.
And then see how the log base 7 to 12 is not acting on the 7 until you rewrite that again. So if the log base, whatever, is acting on that same base, then you can do something. But you had it acting on 49, and then we had it acting on 7 squared. Still ain't going to be able to do something. Had to get that square out of the way by just switching with the way.
Like a question like that came up on a test, find a common base in the log.
Yes, beautiful.
And whatever is left out, just trying to find the answer.
Yeah, or you can work through like this.
Square or cube.
Okay. I like it. Yes.
Can you explain why the 2 moves out for the entire thing?
Okay. Let me ask you this. So x to the 4th to the 3rd power. Is that different or the same as x to the 3rd to the 4th power?
Same.
They're the same. Okay. I mean, that's it. Is that cool? So anything I do that doesn't change what this represents is legal. So when I changed this, of course these are the same stupid thing. When I did this, now you can say the same thing. Of course these are the same thing. Because that product is the same as that product. They're the same. But when I rewrite it like this, now I can do like John was wanting me to. Now I can actually do this because it's acting on that same base. I like it. Now I've gone way beyond what I wanted to. I got to bring it back because it's a little bit beyond where I want to necessarily be right now, and I don't want to drown anybody that's not really up with things. How do you guys feel about the basics of logarithms right now? Let me ask you some more advanced logarithm stuff. Still not too crazy. And you're like, we'll be the judge of that. Aw, you're up here. There you go, buddy. All right, you're a little crooked, but I'll be all right. All right. Let me ask you a succession of things with the same base to try to make a point here. What's log base 4 of 16? 2. What's log base 4 of 4? 1. I'm going to put another problem right here in a second, but let me skip for it. What's log base 4 of 1? 0. Which means now let me see if you guys get this. If I put a number right here that's between 1 and 4, the answer has to be between
0 and 1.
Okay. So if I put a 2 here, yeah, and what are powers between 0 and 1? They're fractions, and fractional powers are really roots. So when I see a number here that is between 1 and the base, it's less than this, but it's more than 1. Then that means I have to apply a root, which means a fractional power. I really want you guys to see that. I'm just trying to help you tease out. This is a weird one because it looks like they're backwards. But really what you can think about it is, if that was a 2 and that was a 4, the answer would be 2. So that's 4, that's 2, the answer is 1/2. Yes. So if it would have been this instead, the answer would have been 2, right? Yeah. So let me do over here for a second. If I had log base 2 of 8, 3. So what's log base 8 of 2? 1/3. Because I got to cube 2 to make 8. That means I have to cube root 8 to get 2. And this is all about how well do you understand powers. And when I say powers, I mean all powers. And fractional powers are roots. How are we doing so far? Logarithms are just all about powers. So the better you understand all the powers we've talked about, the easier logarithms will be. Continue with this. Let me see. Where are we going? Oh, what about log base 4 of 1/4?
-1.
Yes. Do you see how the progression is going? It's got to be less than 0 because I put a number in there that's less than 1. Okay, I like it. And so if I keep making this smaller, the output's going to be smaller and smaller and smaller. Okay, I like to show you this progression. Hopefully you got something out of that. Okay. Okay. Oh yeah, okay. Let's do this. So what is log base B of B? Yeah, again, the answer is the power B needs to become the inside. B to the what power is B? 1. So what's log base B of B squared? 2. All right. So again, it really just these cancel. right? That's the real idea behind this. What about this here? Log base 1/2 of 8. So I wanted to do two things with this. I want to show you that the base can be fractional, right? That's kind of gross. But the first thing you do to it, if it's fraction, is you flip it, so then you can think about it better. So you know the answer is going to be negative something. And what do you do to 2 to make it become 8? 3. So you got to flip the 1/2, make it 2, and then you cube it to make it 8. So you can kind of think of it in steps, right? Which is the same way I told you how to do negative powers, is you flip it and then you do the power part. That's exactly how we kind of analyze this. What about this? What's log base 1/2 of 1/4?
2.
Yeah, 2. Good. They're both fractions. You don't have to flip anybody. You just want to square the 1/2 to make it become 1/4. All right. I like it. I like it. If you don't understand what the log is asking, you can't attack the problem. If you understand what it's asking you can at least start to think about, well, what do I do to this to make it become this? Powers-wise, right? I like it. Okay. That was it for this. Good. Let's see. So you just came in. So I want to talk, well, actually, let me ask you guys, you want to take a break right now? No? Yes? Let's do a break. I think a break might make sense, because then I'm going to go back to 12.1. We're going to talk about a general idea of inverse. You can see it was bold, it was like in capitals on the front page. So we're going to go back to 12 and talk about inverses in general, and then I'm going to make the connection between exponentials and logarithms as inverses much more formalized. Let's take a break. Oh, come back at